Hello. Today, let's talk about graphing quadratic inequalities, such as y is greater than 2x squared minus 3x plus 5. We know this is a quadratic inequality because it has a greater than sign, meaning that it's an inequality, and it has the 2x squared, indicating that we have a quadratic expression. In the past, we've learned how to graph quadratic functions. We've learned three forms for quadratic functions. One of them is standard form. Standard form, f of x equals ax squared plus bx plus c, where a, b, and c are all real numbers. But why do we want a quadratic function in standard form? We like quadratic functions in standard form because they're easy to graph. With the standard form, we have ax squared plus bx plus c. And we can use these a, b, and c to find different values on the graph. For example, the line of symmetry. X equals negative b over 2a is the equation for the line of symmetry. As we can see from the graph, the parabola looks like it is symmetric on both sides of the line. In addition to the line of symmetry, we can find the vertex very easily. Once we have found the line of symmetry, negative b over 2a, we can put that value back into the function f of x and get the y value for the vertex. And the vertex, as you can see, is the point in the middle of the parabola on the line of symmetry, and it's either at the top or the bottom of the graph of the parabola. Now again, our goal today is to learn about graphing quadratic inequalities. We've already discussed graphing quadratic functions. Another thing we've learned in the past is graphing linear inequalities, such as y is greater than 3x minus 5. Now we will review how to graph y is greater than 3x minus 5 or other linear inequalities. We have learned 3 steps to graph linear inequalities. The first step is to graph the linear function. In this case, f of x equals 3x minus 5. Now our second step for graphing a linear inequality involves determining whether the inequality is strictly less than or greater than, or if it is less than or equal to or greater than or equal to. If it's strictly less than or greater than, then we make the line dashed. Otherwise, we leave it as it is. Our inequality, y is greater than 3x minus 5, is a strictly greater than, so we'll make the line dashed. See, we have now made the line dashed. Our third and final step in graphing a linear inequality is to determine which side of the line to shade. In order to do this, we will test a point on one side of the line. If it is a solution to the inequality, then we shade the side that the point is on. Otherwise, we shade the other side. The point we will test to see which side of this inequality to shade is 0, 0, because it is easy to use. We have now shaded the side of the line where the point 0, 0 is, in order to represent that all of the points on that side of the line are solutions to the inequality y is greater than 3x minus 5. So far, we've reviewed graphing quadratic functions as well as graphing linear inequalities. Now we will combine these ideas to figure out how to graph quadratic inequalities, such as, just as graphing linear inequalities, the first step to graphing a quadratic inequality is to graph the quadratic function. In this case, f of x equals 2x squared minus 4x minus 1. In order to graph the quadratic function 2x squared minus 4x minus 1, which is in standard form, we will start out by using the equation to find the line of symmetry, x equals negative b over 2a. The line of symmetry is drawn here, perpendicular to the x-axis at x equals 1. Now that we've graphed the line of symmetry, we want to also graph the vertex point so that we can graph the parabola. We know that 1 equals x is the x value of the vertex. So we will put this into the function to find the y value of the vertex. Our vertex is at the point 1, negative 3, as shown on the graph. Having graphed the line of symmetry and the vertex, we will now graph two other points near the line of symmetry in order to complete the graph of the parabola. First, in the next step, we used what we know about the axis of symmetry to create points on the opposite side of the axis of symmetry as the points that we had already found. And then we connected the points to create the parabola. And now we've graphed the quadratic function. Our second step in graphing a quadratic inequality is the same as if we were graphing a linear inequality. We look to see if the inequality is strictly less than or greater than, and then, if it is, we make the parabola dashed. Otherwise, we leave it like it is. In our case, the parabola was less than, which is strictly less than, so we made the parabola dashed to show that the points on the parabola are not solutions to the inequality. The third step involved in graphing a quadratic inequality is the same as if we were to graph a linear inequality. Again, we test a point, this time inside the parabola. If it is a solution to the inequality, then we shade the inside of the parabola. Otherwise, we shade the outside of the parabola. The red point is inside the parabola on the graph shown here because it is in between the two parts of the parabola in the direction that it's opening. The green dot is outside of the parabola because it is not in between the two sides of the parabola. We will now test the point 1, 0, which is inside the parabola, to see if it is a solution to the inequality. We have 0 is less than 2 times 1 squared minus 4 times 1 minus 1. This simplifies to 0 is less than 2 times 1, because 1 squared is equal to 1, minus 4 minus 1. This simplifies to 0 is less than 2 minus 5, because minus 4 minus 1 is minus 5. And then 2 minus 5 simplifies to minus 3, so we have 0 is less than minus 3. This is not a true statement, so we know that the point 1, 0 is not a solution to this inequality. So we will shade the outside of the parabola. We now have shaded the outside of the parabola. The shaded region is all of the solutions to the inequality y is less than 2x squared minus 4x minus 1. And now we are done graphing this quadratic inequality.